Hey honey, I'm home. Honey, where are you? 911, what's your emergency? Please come quick, my husband's been murdered. Hello, ma'am. I'm the detective on your husband's case. I am so sorry for your loss, and I promise you I will find who murdered your husband. Hello, ma'am. We've come back because we've discovered who your husband's killer is. What? How have you done it? We use a special thing called forensic science. Forensic science is the use of scientific procedures to help with a criminal investigation. A forensic scientist will go through a series of tests with physical pieces of evidence to either help with the understanding of the crime, narrow down suspects, or determine a criminal. The results from the test is then presented in court so it may help with determining one's innocence. Prior to doing tests on the evidence collected, we had to determine if your husband was being affected by any drugs, alcohol, poison, or any other substance that could have impaired him. To determine whether or not a victim has anything in their system, a toxicology test is ran on a sample of their blood, urine, saliva, tissue, or any other bodily fluid. We use the immunoassay technique, which helps to determine possible substances in the body. This technique involves adding antibodies for a specific substance. If that particular substance is in the victim, these antibodies would combine with it. Then, a signaling antigen is added to the sample, and these antigens would combine with any other remaining antibodies. If all the antibodies are reacted with the antigens, then the specific substance is not present in the body. However, if there are less antibody-antigen combinations than the number of antibodies originally added, it means that some must have combined with the substance. This suggests that the substance in question was present in the victim's body. After toxicology, we began tests on the evidence. The first piece of evidence was the shoe print found at the crime scene. There are 3 different types of prints: visible, which we can see without the help of chemicals; plastic, which is a print created on a moldable surface, like snow; and latent, which needs the help of chemicals for it to be visible. With all evidence, it is important for us to take photographs for analyzation and to present at court. For visible prints, the footprint must be taken at a 90-degree angle. Latent prints are a bit different because we need to use the oblique technique, which involves using a forensic light source. This light displays different bands of wavelength or light, which helps to identify the small particles. The light can range from 365 nanometers to 700 nanometers, and the pictures are taken at many angles to produce different amounts of lighting and to enhance the contrast and detail of the particles. These photos are then altered in certain editing systems to help magnify the detail and quality so important characteristics are noticeable. From these prints, shoe size, height, and size of the suspect could be determined. The next step is to preserve the print. The only way to preserve visible print is through photography. For plastic prints, the casting method is used where a dense liquid is poured and left to harden so the print may be lifted in one piece. Latent prints are preserved using different lifting methods. An adhesive lifting technique is used for dusty prints. Adhesive paper is placed on the print and the impression is transferred onto the paper. To make the dust visible, the paper is treated with 0.05 grams of crystal violet and 500 milliliters of distilled water, which would stain the print. The next technique is the gelatin technique, where a sheet of gelatin is placed on the print, and since it is flexible, it is able to get into small crevices and preserve the details of the print. The most common technique is the electrostatic dust print lifting device. This device would charge the particles of dust or soil, which makes them attract to the film. This attraction transfers all dust and soil to the film for an accurate representation of the print. From the print of this crime scene, we were able to determine shoe size and general height and size of the suspect. Next, we examined the fingerprints found at the crime scene. Fingerprints are created from the ridges on the pads of our fingers. Prints vary from person to person. Identical twins may have similar prints, but there are very small differences that distinguish each individual. Just like shoe prints, fingerprints may be visible, plastic, or latent. Visible prints are formed by transferable substances like blood, dirt, or paint. Plastic prints are made on moldable surfaces, and latent prints are made out of natural oils or sweat. In your husband's case, there were many latent prints that we had to preserve. Latent prints may be preserved multiple ways. One way is the cyanacrylate method, which involves the gaseous form of the chemical cyanacrylate coming in contact with the material that contains the latent fingerprint. The chemical reacts with the residue from the print, which may include amino acids, glucose, peptides, ammonia, and other inorganic chemicals. The reaction leads to the print changing color and becoming visible. Another common method is using fingerprint powder, which is very fine powder that adheres to the residue left from the finger. For your husband's case, we used this method on the fingerprints found on the murder weapon. For the test, we needed fingerprint powder, a brush, lifting tape, and a printing stamp. The first step is to take the brush and dip it into the powder. Next, we lightly dusted the powder onto the material. Slowly, we saw a print beginning to form. When done, blow off the leftover powder. Next, place lifting tape onto the print and slowly push down. When peeling off the tape, you can see that the print is attached. Place the tape onto another card for later inspection. Fingerprints from all suspects should be collected with the finger stamp, allowing experts to compare the suspect's prints and the original print. Experts would examine the two sets of prints to determine if it belongs to a suspect. They use classes and characteristics for these determinations. The three classes for fingerprints are arcs, loops, and whorls. The most common class is loops, followed by whorls, and finally arcs. Characteristics are irregularities that are unique to an individual. These irregularities are referred to as Galton's details, and the most seen details are bifurcations, ridge endings, and islands. Examiners would use these classifications to determine if a print belongs to a suspect. Another piece of evidence that was important in the investigation was the piece of hair we found. This was crucial to us because we were able to create a DNA profile that we could compare to the profiles of our suspects. Our DNA has sections called polymorphisms, and these vary from person to person. A type of polymorphism is called short tandem repeats, which are unable to be coded and appear at the loci of the chromosomes in DNA. Because of their uniqueness, experts would examine the short tandem repeats in the loci, usually more than 10, to create a DNA profile. The first step in DNA profiling is to extract the DNA from the nucleus and separate it from other cellular fluids and proteins. Once separated, the DNA must be replicated using a polymerase chain reaction. The short tandem repeats are then separated using gel electrophoresis, which is a method used to separate the short tandem repeats by pushing them through an electrical field with a positive and negative electrode. Since DNA is negatively charged, they get attracted to the positive end of the gel, separating the short tandem repeats by the size. This process results in creating a profile that may look something like this. Now that all of the tests are out of the way, here are our suspects: the mailman, the neighbor, the cook, the butler, and the babysitter. With our results, we figured out who of the 5 suspects killed your husband. We ran a toxicology test, which used antibodies and antigens to determine if the victim had any substances in their system. This test revealed that there was nothing in the victim's body at the time of the murder. Next, the shoe print was photographed with different wavelengths and could have been preserved through many different methods, like adhesive paper and the electrostatic dust print lifting device, which created an attraction in the particles to the film. We found the shoe size to be a size 8 and the height to be about 5'7" to 6'2". Next, the fingerprint was examined using fingerprint powder, and the DNA was extracted from the nucleus and put through a gel electrophoresis device to separate the short tandem repeats to create our DNA profile. With the shoe size being a size 8, we were able to eliminate one suspect, the mailman. The estimated height of 5'6" to 6'2" eliminated a few people from our list, the cook and the babysitter. With 2 suspects left, we have to rely on our fingerprint. When we collected the fingerprints from the butler and the mailman, one of them matched with the one found on the murder weapon. To be sure of our results, we compared the DNA profile, and sure enough, it matched. With all of the results leading to a single person, we can confidently say that this person killed your husband. The person who killed your husband was the butler.